Good morning, my name's Jeff Houston. I'm with APNIC. This was a lightning talk, but we've got some time so I can take it a little bit slower if you want. You know, the universe runs at 2.3 degrees Kelvin. Anyone know that? The reason why it runs at 2.3 degrees Kelvin is that's the echo of the Big Bang of some 13.7 billion years ago. And if you sort of stick your hand out there in raw space, you'll get these little bubbles of microwave energy just going bing, bing, bing at a rate of 2.3 degrees Kelvin. Now, oddly enough, that's not the only thing that just sort of radiates in the dark. V4 radiates in the dark. If you stick your router in an unadvertised part of the address space and just listen, you're going to get, on average, one packet every 2 seconds. Bing, bing. And that packet's toxic. In fact, it's not quite like that. If you're lucky enough to have an IP address in the bottom half of a /8, you know, anyone from a .1 to a .128, anyone got one of those? Come on, hands up. Loser. Because configure hits the low half of every /8 at about 10 times the rate of the high half. So if you're in the low half, you get about 5 packets every second. Bing, 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 all at port 445. Right? So most of this background radiation in V4 is incredibly toxic. It's just basically aimed at all those Windows losers out there. And it runs at about, if you total it all up, at about 5.5 gigabits per second across the entire V4 space. And there are some 24s that are just incredibly toxic. Who owns 1110/24? I do. That's real shit. That's about 100 megabits per second of just complete crap. Oddly enough, that's not all configure, that's actually SIP. But you know, if you own V4, it radiates in the dark. Now, the real question is, well, that's V4. What about V6? Because if we're so good, and we're bloody expert about actually generating toxic crap in V4, how well are we doing in V6? And will V6 really be considered a mature technology until it radiates as well? So I thought it was actually time to figure out exactly what's going on in V6 and has it reached maturity yet? Now, fascinatingly, I have this huge playpen inside V6 because some time ago, back in 2006, all the RIRs got given /12s. You know, in V4, /12 is kind of ho-hum, bit boring, but in V6, it's enormous, isn't it? Huge amount of space. And oddly enough, we've been really working hard in allocating V6 addresses over the last 4 years, so hard that out of that /12, we've allocated a phenomenal 1.59% of it. So, in other words, 98.41% of that block is entirely vacant. So I thought I'd advertise it. Did anyone notice? Congratulations, sir. The only one in the room that actually noticed. You're right, actually nobody noticed. Someone actually advertised a /3 in V6 over the winter last year. Did anyone notice that? Well done, only 2 of you. Was that one of you two, by the way? Someone did it, and I was wondering who the hell it was. Interestingly also, not everyone who gets V6 address space advertises V6 address space. So that when I actually look at the difference, we did 709 allocations, 1.59% of a /12, but there are only 323 advertisements. In other words, only 2/3 of the space is actually advertised, the rest is not. This is fascinating. So anyway, Martin saw it, no one else did. I did advertise this in June. It was advertised by AS 7575. It was purely passive. It's actually really hard to do spoofed source addresses in V6, unfortunately. I don't know why, to make it a lot more fun. So anyway, here's what I found. This is actually a graph of the received traffic. The scale is linear, and what it shows is around 500 kilobits per second of dark traffic hitting this listener. And most of it, oddly enough, is ICMP. It's not UDP and it's not TCP. That is different. When you look at the V4, you'll find that in the configure part of the world, it's all TCP SYNs. And in the other half of your /8, in the high half, it's actually all UDP just fishing around. but there's very little ICMP, whereas in V6 this is almost all ICMP. So half a megabit per second in a /12. And someone was trying really hard, full points for effort. They actually managed a peak of 3.5 megabits per second and sustained it for a whole second. Well done, guys, you're doing really well. Talk about the blind leading the misguided to stupid places. That's what V6 is all about. How the hell can I get, in an unadvertised address space, a destination unreachable? Now think about that. Someone's obviously sent a packet to some crap place that doesn't exist. And the router in the middle says, oh, I don't know about that. I'm going to send you back an ICMP destination unreachable. But they don't get it, I do. Think about that again. It really is a double misconfig. They don't know where it's going and no one knows where the packet came from. And guess what? 3/4 of the traffic is this shit. So 3/4 of the dark traffic is just the blind leading the blind to all the wrong places. And the rest is just a mere smattering of UDP and TCP. So, okay, I start to split this up, and what I actually find when I sort of analyse this on the /20s is that there really is only one /20 that's causing all of this dark traffic. So that big red peak in the middle, and this is logarithmic, so it stands out like a sore thumb, is where all this traffic is going to. This is NTT East. Most of the dark traffic I see is going to an unadvertised block that was already allocated to NTT. Now, what does NTT do with this block? It uses it for IPTV. And do they charge for traffic in this address block? Because it's used for TV. Who could possibly think that people would reprogram their boxes to use traffic inside basically a free sideband? Not me, and not all the rest of those other people who then take their configured laptop into a public space and leak traffic like crazy. So basically most of this traffic is actually leakage coming out of NTT. And if I look at all the rest of it, most of the rest of this traffic is actually leakage from allocated space. It's just folk who don't quite figure out that routing doesn't work properly in V6. There is no such thing as a private network. I might just get over it. And even if you don't advertise your address space, you're still going to leak like crazy. There is no RFC 1918 space in V6, so what we actually see when we set up dark stuff is a huge amount of traffic leakage. So let's try and split the two. This is trying to... Oh, come on. What I was trying to show was there's this red line. I give up. I get down to one packet every 38 seconds in V6 of dark traffic. And basically what I find is there's almost nothing coming through in V6. The dark traffic in V6 that's truly dark, going to addresses that don't exist, is actually nothing. What I actually find when I listen in a /12 is one packet every 36.8 seconds. And most of that packet count is actually still ICMP. You remember the blind leading the blind nowhere? That was all I really saw. Now, I started to look at this a bit more, because there's only a few packets. You can actually look at every last one. Now, this is fascinating. 1,126 SYN packets. Hello, are you there? I have no idea who you are. You've probably stuffed up the DNS. I'm going to send a packet into the dark land. Cool. A SYNAC? Now, hang on. I'm dark. This is not real. Someone is sending me a SYNAC. Where did they get the SYN from? Who the hell can't configure V6? Hands up, everyone. Every last one of you. You just can't quite get these numbers right, because there are far more SYNACs than SYNs. This should not happen. And best of all, and I love it, there are 148 data packets. Somehow those two machines managed to exchange a SYNAC and then forget they ever existed to each other, and I'm seeing the data packet as a result. Whoever's doing that, well done. Wow. Is anyone here from University of Pennsylvania? You've got to explain this packet to me. It's a ripper. This is a DNS TCP data response without a handshake. I'm just seeing the result. Someone's just decided to launch into the ether, into Network 2400, a DNS response. Why? And then there's TCP probing, same source address, no preceding SYNAC, just probe packets, coming from the Harbin School of Engineering in China, I believe. And they're having a fine old time there. And the other thing too, here's Teredo going completely bizarre. Same source address, it's just probing through destination addresses. Having a fine old time, most of it length 0. And this one I like, this one I really like. This is this whole dual stack problem. How many people run dual stack? How do you know you've got your v6 correctly configured? How do you know? Because this guy obviously didn't. Because what's going on is that he's stuffed up the address of the mail server in v6. And every time he tries to send mail, he tries to send it to Hurricane Electric's mail server. Well, this is all well, good and fine, except he's got the address wrong. So I get the SYN packets. So he decided to send 780 emails, and he tried to send it to me 780 times. But because he's dual stack, he never noticed. You know, it tried TCP SYN in v6. Oh, obviously v6 is out to lunch. I'm going to use v4. How many of you know your v6 is working in dual stack? Because I can bet you most of it doesn't. Because what's going on is that we see this huge amount of v4 patching over the errors in v6. That's a typical example there. Someone's got their DNS completely stuffed too, 2,892 queries into dark space. And again, I'm not answering these things, but because they're dual stacked, whoever's sending the packets never notices. Because the fallback to v6 patches up all of these kinds of errors. And the other thing, of course, dark ICMP, this is his echo request, 7,800 pings. Pings into absolutely nowhere, and 93 other just completely bullshit packets. So what do you see inside v6 to actually look at it? v6 isn't toxic. You can't address scan. Let's go through some of these numbers, because I kind of like it. Remember the age of the universe, 13.7 billion years? So let's just do a little thought experiment. You know, I have this address scanner, and it can scan ports at a rate of, 1 million a second. How long would it take to scan all of the v6 addresses in a /48? Any guesses? 55 billion years. In other words, a little bit over 6 times the life of the universe. You cannot address scan in v6, and we see no address scanning there at this particular point. In other words, what we actually see is that routing does not create security, and that most of the traffic we actually see is actually leakage from private use contexts. Private networks aren't private. And the other thing is, no one can type in a v6 address and get it right, as far as I can see. They just don't actually understand to get those hex digits right. And most of those errors, because of dual stack, go completely unnoticed. It just looks like your machine's a bit slow, but because most machines are virus-ridden with configure anyway, no one notices in the first place that it goes a bit slower. So as far as I can see, the v6 traffic actually really isn't all that bad, but what happens in v4 in terms of toxic traffic doesn't translate into v6. We're not seeing virus scanners because they're not going to work the same way. Address scanning actually doesn't work. So v6 isn't secure, but what we are going to find is that as v6 matures, the way in which toxic traffic is going to appear in v6 is that it's going to use crawling through DNS in order to do the rendezvous, because blind address scanning isn't actually going to happen. Thank you very much. And I've been told there's time for a few questions if you've got any. Anyone here from the University of Pennsylvania? What were you doing? Nope. Okay, thank you. I'm going to pull that out then.
Thanks, Jeff. Thanks, Jeff. Okay, so we have a few extra minutes, so I think what we're going to do now is take a little bit of an extra break, and then we'll come back at the same normal time. One thing that you guys can do is fill out the survey. Okay? All right, so see you after the break.